Have you ever stopped to ponder the vastness of the cosmos and our place within it? Picture, if you will, a time when we believed the universe spun around us, Earth at its center. This is the geocentric model, a cosmic concept that held sway until the late 16th century. Imagine a universe where all celestial bodies, the sun, the moon, the stars, and the planets, danced in circles around our planet. This Earth-centered view was not born out of arrogance, but a logical understanding based on observations at the time. Greek philosopher Aristotle and astronomer Ptolemy were the key proponents of this model. They observed the heavens and concluded that we were at the center of it all. Their influence was so immense that the geocentric model was widely accepted for centuries. But, as with all scientific theories, it was put to the test. Despite the geocentric model's widespread acceptance, it was not without its critics and inconsistencies. Enter Nicholas Copernicus, a Polish mathematician and astronomer who dared to challenge the status quo. In a time when the Earth was considered the centerpiece of the cosmos, Copernicus proposed an audacious concept, the heliocentric model. He placed the sun, not Earth, at the center of the universe. The planets, including our own, were merely celestial bodies, orbiting the sun in perfect circles. This idea, however, was met with fierce resistance. Religious and scientific communities alike found it hard to swallow. The very notion of Earth not being the center seemed outrageous, even heretical. Yet, the heliocentric model brought answers. It elegantly explained astronomical phenomena that left the geocentric model stumped, such as the retrograde motion of planets. But despite its explanatory power, the heliocentric model remained largely ignored by mainstream scholars. It was not until Galileo Galilei entered the scene that the heliocentric theory gained wider acceptance. Galileo Galilei, an Italian polymath who's often called the father of observational astronomy. Galileo, armed with his improved telescope, peered into the night sky, and his observations would shatter the geocentric model. He discovered celestial bodies orbiting Jupiter, challenging the belief that all heavenly bodies circled Earth. His findings of the moons of Jupiter were a strong endorsement for the heliocentric model. Galileo also observed Venus going through phases akin to our moon, indicating it orbited the sun and not Earth. These observations were like puzzle pieces falling into place, supporting the heliocentric model. However, his support for this revolutionary model was not without consequences. The Church, holding the geocentric model as a religious truth, found Galileo's findings heretical. This led to his trial and subsequent house arrest. But Galileo didn't back down. His unwavering conviction and contributions to astronomy were pioneering. Galileo's persistence in the face of adversity ultimately laid the groundwork for our modern understanding of the cosmos. The transition from the geocentric to the heliocentric model represented more than just a shift in scientific understanding. It was a revolution, a fundamental change in how we perceive our place in the cosmos. Before, we saw ourselves at the center of it all. Now we understood we were but one small part of a vast, swirling universe. This shift was not merely about planets and their orbits. It was a gateway, opening up a world of further scientific discoveries and advancements in astronomy. It was a spark that ignited an insatiable curiosity about the cosmos, leading us to unravel mysteries about black holes, galaxies, and even the origins of the universe itself. But perhaps more importantly, this shift underscored the necessity of questioning established beliefs and seeking evidence-based truths. Galileo's courage to challenge the status quo not only changed our understanding of the cosmos, but also serves as a timeless reminder of the power of curiosity and the pursuit of knowledge.